All right, pupil group. I had a few minutes to think about this project, so I am doing that, and I thought I'd record my thoughts so that you guys can be on the same page in terms of where we may be going with this. So I know you guys are working on this, looking up papers that measure the pupil in some way, and in anxiety or emotional disorders, like mood disorders, and trying to see what people generally do with this sort of a data set, to sort of open your mind as to what questions we may be able to ask with it. So that's sort of one way to come up with a research question, be like, oh, look at that, somebody else asked this question, that was a cool question, they asked it with this group of people that's slightly different than our group or whatever, or doing a different task than we did. And so we can just ask the same question they did, but apply it to our group of people, our anxiety people, or our people who took oxytocin, or our during our other emotion recognition task, they did a different task or whatever. So you basically steal their idea and just, it's still an interesting question, but we have a slightly different version of it because we have a different group or whatever. So that's one way to come up with a good question. Another thing that constrains or guides the questions we can ask is the sort of data that we have, and we can just kind of logically think through, okay, what questions can we ask given the nature of the data that we have. So I wanted to show you guys more about the data that we have. So you remember last time during the meeting I showed you an Excel sheet that was like 80,000 rows long, and it had every second the eye tracker samples where the eye is looking 120 times per second. We call that 120 hertz. That's what 120 hertz means. That's the frequency of sampling. So 120 times a second. And so that results in, over the task, which is like 10 minutes long or whatever, 80,000 rows of data, or whatever it was, 85, I don't remember. But it was a lot of data. And so we have basically a few variables we don't care about in that Excel sheet that I showed you, and then there were three that we really do care about a lot, 3 or 4. One of them is the pupil size. So every frame of data, 120 times a second, we get how big is the pupil, how big is the pupil. And then we also have where's the person looking on the X plane and on the Y dimension or whatever, where are they looking. So those are 3 variables that we have. And then we also have, what trial is it? Is it the first trial? Is it and when I say trial, I mean the way the task works is the subject looks at the screen and then a face comes up on the screen. It's a neutral face, and gradually that face morphs into an angry face or whatever, and the trial presses spacebar to end the subject presses spacebar to end the trial when they know what emotion it's morphing into. So that would be one trial, going from neutral to angry and then pressing the spacebar. That's one trial. And we have information in our big data sheet, which trial was it? And we can, so those are basically the 4 variables we have. And what we can do is, see, I've set the subject ID to be 474. This is arbitrary, it's one subject. And we can run this program. And when we do that, see, it says on the corner here, busy. That's because it's doing all these lines of code here. There's like 500 lines of code. It does a lot of cool things with the data, and it analyzes the X and Y position of the eye, and it analyzes stuff about the pupil, and it tries to filter out some data that like don't make sense or that are missing or something, and we get all these nice pieces of information. So for us, we're interested in especially the pupil data. So see here, this file that was created, 474pupesize.fig. That's that's this figure here that was just generated by me running the program just now. It made this figure, and it shows the pupil data on each trial. So this is trial 4. Xstat 4 means it's trial 4. So whatever, I don't know what face was shown on trial 4, but say it was maybe a sad woman's face. You know, it starts as neutral and it morphs to sad. So what happens is every trial, you see it sort of does this dip thing. The pupil is very large and then it shrinks. So the pupil size is on the x-axis. And the y-axis is just the frames that were collected on that trial. So this trial here, 800 or 900 frames of data were collected on trial 5. you divide that by 120 and it's like 7 or 8 seconds that the trial took. This trial took longer, took like almost 10 seconds because it was almost 1,200 frames. This trial took even longer, almost 20 seconds for the person to identify the emotion and then press the spacebar. So you see different trials are different lengths. But what happens is there's this dip at the beginning in pupil size, and then the pupil kind of fluctuates, in varying ways. So the pupil got big here and then got small. That's what happens on each trial. And that you guys are looking in the literature to see what people do with pupil data. So I'm interested to see what you find. But I also wanted to let you know what I'm thinking off the top of my head, which I've never done a pupil study before. But this is what would occur to me, which is that, first of all, we want to sort of filter these data a little bit and clean out the artifacts. And when I say artifacts, I mean meaningless aspects to the data that are not what we're interested in, but they would affect. I mean, one thing we could do is like, so we're interested in pupil size, how it's different in people that are anxious, or maybe it's different in people that had oxytocin versus the placebo, right? And what if we show people with anxiety have bigger pupils? They're more aroused during the trial. That is actually a good question. So one thing we could do is just take the average of the pupil size during this entire trial. Trial 15. What's the average? It's probably like 38 or something. If we average, see, it's almost 40 here. We could look at this entire trial, and the average is 38. Okay, great. And we find that that's the pupil size for that person on that trial. And people with anxiety have bigger pupils than people without. I mean, that would be one interesting question. But I think it's a little bit crude because, we're doing this emotion recognition task, and we're interested, usually the way people think about these tasks with anxiety is that if you're an anxious person, especially if you're socially anxious, and there's a threatening face, like a face that's afraid, like which would signal to you as a fellow member of the pack of that person that you're looking at that there could be a danger if they have a fearful face, or if there is an angry face that would make you feel afraid also. It would arouse you, your fight or flight response. So the anger and fear are sort of two threatening faces. So it might be more interesting to look specifically at those and say, okay, people with anxiety, do they have bigger pupils just on those trials where there are threatening faces of some kind? But the thing, so that's getting us a little closer to a more precise question, I think. But then another aspect to consider is, okay, at the beginning of each trial, the subject can't perceive an emotion. The subject doesn't know what emotion it is, because remember, every trial starts off as a neutral face. So for example, this trial 27, the face is totally neutral at the beginning. And it gradually morphs towards an emotional face to the point where the subject presses the spacebar right here and ends the trial because the subject knows what emotion it is. So this stuff here at the beginning, how aroused the subject was or how big their pupil was at the beginning, isn't that important to us because they're just looking at a neutral face. It's this stuff at the end where they're starting to see, it's probably a sad face, and then finally they press the spacebar, or it's an angry face, whatever. This would be the most interesting stuff to me. And one way we could look at the data would be to compare the size at the end with the size at the beginning. And I would say we'd probably want to look after this little dip occurs. What this dip is just between every trial, there's a blank black screen shown. And what that does is it lowers the level of brightness in the room, and the subject is basically in a very dark room between trials because the screen isn't providing like a bright light on them. And so their pupil grows because our pupils get really big in the dark, right? So we can see. And then what happens is when the stimulus comes up at the beginning of the trial, the pupil shrinks because it's a brighter situation than it was between trials with just a blank dark black screen. So that's what's happening with this pupil shrinkage at the beginning of each trial. And I think we probably just want to ignore those data so we can start looking at the data after that, like say 200 milliseconds in or something, after the pupil has kind of done its thing. And then we can compare that to the stuff at the end. So for example, this trial here, trial 39, we look at, say, a few hundred milliseconds of data right here. We average it. We say, okay, 32 is what it was at the beginning. And then at the end, they got aroused. It was 38. And so that's a difference of like, 20% or whatever in pupil size. So that would be our number that we get out of trial 39 is a 20% pupil increase, or 20% pupil dilation. And then we might find, oh my gosh, people with anxiety tend to have higher percentages of pupil dilation on the threatening trials. That's sort of the layup. The most direct question I can think of to ask with these data would be something like that. Another way we could look at it is to say, okay, ignoring again this pupil dilation at the beginning, what's the slope of this line? If I took a line of best fit from say here to here, what's the slope? And if I could just use, instead of percentage difference of this pocket to that pocket, I could just take the slope. And to be honest, it's probably going to end up being pretty redundant with that percentage difference, but we could do the slope of a line of best fit, or we could just sample the beginning and the end and calculate a percentage difference. So that's what I'm thinking. You guys let me know what you're thinking. And I think that this is a good project. This is a good data set. And we'll be able to find something interesting here no matter what the results are. So let me know what your questions are. I know I went through that pretty fast. But yeah, I think this is a good way, maybe sending videos back and forth, or you can email me back in response to this video what your thoughts are and what your questions are, and that way, hopefully by Friday, we'll be able to really get a data set underway where we calculate, say that percentage value or whatever for every subject. And then we can compare that to their anxiety levels or to whether they took oxytocin.